Hey there, today we are going to cover the last three clusters of kindergarten featuring numbers and operations in base 10, measurement and data, and then ending with geometry. So let's start with number and operations in base 10. So this cluster is directly related to the standard KOAA3, where students needed to know how to decompose numbers less than or equal to 10. So this is what we ended with in the last lesson last week, only expanded now for numbers 11 through 19. So some of the same techniques that you used for numbers 1 through 10, you could then redo for 11 through 19. So some common manipulatives would include counters, 10 frames, linking cubes, number cards, and straws, groups of straws. So at this point, we know how to count to 10 and that the number of objects represents our numeral. Now we're going to group our 10 objects to represent one group of 10. So for example, let's say we have some moons here as our objects, and knowing that we can use all kinds of different objects to represent numbers is key and important for students, so that students don't just represent numbers saying that one represents a flower or one means um, just a star or something like that. Make sure that you're using a bunch of different objects so that students get the idea that we can count all different types of objects. So what I did here was we have 10 moons and we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 moons and I grouped them in a box. So we have one group of 10s and 0 ones. Well, if I have one group of 10s here and I add a single moon by itself, we now get 11. If I have a group of 10s and I have two single moons, I now have 12. And we could continue this pattern over and over again. So let's build to 17. So we knew how to build to 11. We knew how to build to 12. So a group of 10 plus how many will give us 17? Well, what we can do then is add 7 individual ones. So a group of 10s plus 7 ones gives us 17. So 10 plus 7 equals 17. Let's look at another manipulative to represent 14. So let's say I have our group of straws here. So I've bundled 10 groups of 1. So now I have one group of 10. And I have 4 individual straws hanging around. Well, I can also attribute that to my 10 frames. So I have one group of 10, which is the same as having 10 counters in my 10 frame. And then I would need to grab 1, 2, 3, 4 more counters to put into another 10 frame to represent 14. And then I can make my equation. 10 plus 4 is 14. Another way to look at it is our base 10 pieces or our block pieces. If I were to stack 10 units on top of each other and squish them together or snap them together, that would be one group of 10 to represent 10 in our 10 frame. And then further the equation, adding 4 single units represents 4 pieces in our 10 frame. So the equation stays the same. Let's move on to measurement and data. So students need to describe measurable attributes of objects such as length or weight. They need to describe several measurable attributes of a single object. They need to compare two objects with a measurable attribute in common to see which object has more of or less of the attribute and describe the difference. So for example, to compare the heights of two children and describe one child as taller or shorter. They further need to classify objects into given categories, count the number of objects in each category, and sort the categories by count. So some common manipulatives in this section would be objects to measure or weigh, such as toys and books, non-standard measurement tools such as counting cubes, string, straw, paper clips, or crayons, Objects to sort, such as buttons, toys, keys, coins, color cubes, attribute blocks, and dollar bills and or coins. So lots of feeling, touching, handling. We first want to start by going over non-standard units of measure. So it's important to identify what is the unit we are measuring with first. And emphasizing unit is so important when we move to fractions in third grade and introducing fractions in second grade. The unit is very important, so students know exactly what they're measuring with and what is being measured. So, for example, if we take this blue pencil here, if let's say we're using the blocks as the unit, so we would need 15 of those blocks to measure the same length as that pencil. But let's say if we decide to use paper clips lining them up end to end, we would only need 6 paper clips. So depending upon the unit depends upon how many we'll need. Similarly, looking at that bar, if we used our handspan, it would be 6 handspans long, but the bar is 4 feet long, and they have feet in quotations there because it's basically looking at just that particular foot in length, or shoe length might be more appropriate. So again, depending upon what our unit is, depends upon how many we're actually going to need. So let's sort objects by height. So first we need to know how to make height comparisons. So I have different heights of some pictures of owls here, and I have I put together 5 snap blocks together. And I'm just going to look at, for example, this owl here. He seems to be about 1, 2, 3, 4, 5 snap blocks tall. But if I look at the shortest one here, I see he's only 3 snap blocks high. So far, if I were to arrange them, I'd put the third owl first and this one's next because I don't know who would come next. Then I can move my blocks over and I would see that the last owl is 1, 2, 3, 4 blocks high. And the first one is approximately just over 3, but not quite 4. So I would be able to go ahead and rearrange my owls based on where they fall on the height comparison of my snap blocks. You could also ask the question, name something in the classroom, such as something taller than me, something taller than you. And what is the tallest object in our classroom? Noting that there is a difference between the tallest object and the highest object, because I might be able to put a book on the very top shelf, but the book itself is not the tallest, however, it is the highest. So play on words is important to go over as well. Let's say I saw a giraffe, an elephant, and a monkey at the zoo. Which do you think was the shortest, the tallest? And asking students to describe how they know or what their thought process is extremely important so that you know that they're on the right path, and it may help other students as well. Further, the more that they can explain, the more that they understand and they're not just guessing. And then following up with, how could we be sure? So I want you to stop the video and reflect a little bit. How would you tell which is the shortest? What would you do? What describing words would you use to be able to identify which is the tallest, which is the shortest, and how can you be sure? Take a moment, write your thoughts down, reflect a little bit before we move on. We're going to now estimate and measure length. Using the color tile below, the red one there, how many color tiles long do you think the shoe will be? Take a moment before going on to the next slide. Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 color tiles long. Now note that that is our unit. So depending upon which unit we're using, it could be different. So you might want to, with students, use different objects to estimate length, such as we did earlier. Paper clips, hand spans, an eraser. Was your guess close? Oh, here we are. If we were to measure using a chalkboard eraser, would our answer be the same? Why or why not? Grab another object in the classroom, make an estimate, and measure using color tiles. So we could practice this over and over and over again with many different objects around our classroom. Short videos such as Sesame Street's version of Light versus Heavy also gives an opportunity for an introduction to a topic before students have an opportunity to weigh different objects themselves using scales within the classroom. In our lesson straight underneath, watch the Sesame Street video on lighter versus heavier, then come back to our video lesson. So what do you think will weigh more, an apple or a pumpkin? To do that, I'm going to go to our manipulatives, our virtual manipulatives, and we're going to check it out. This link is in our online manipulatives. So I have an apple, and I'm going to put it on my scale, and I have a pumpkin. And I can see that the pumpkin weighs more than my apple. Next question, which do you think will weigh more, a bowling ball or a football? So going back to my scale here, let's put our bowling ball and let's erase, let's start over here. Okay, so let's do a bowling ball and a football. This activity would be fun if I had a scale that we could show and practice in class, so something hands-on for students. If we added another football, will the scale stay the same? So we see that the bowling ball is much heavier than the football. So if I added another football, ooh, our scale didn't move much. How many footballs do we need to add for the footballs to weigh more than the bowling ball? So far we added 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, looks like we're weighing the same, 14, looks like we're starting to tip the scale, 15, 16, 17, 18, 19. I would say anywhere between 14 on would definitely get us past the bowling ball stage. You play around with this a little bit. What is something that might weigh less than a football? And there are umpteen questions that you could come with a scale and bring to class for students to try. Let's say we have the following attribute blocks: 3 small, 3 large of each shape, and yellow, red, and blue. Pause the lesson and brainstorm some ways that we can sort these pieces. So just jot down some ways that we could sort these pieces out. We could sort them by color, by size, by shape. And if we sorted by color, how many groups would we have? Looks like we have blue, yellow, red. If we sorted by size, how many groups would we have? Looks like we have big ones and little ones, so 2. If we sorted by shape, how many groups would we have? Looks like we have 3 different shapes: circles, rectangles, and triangles. Imagine if we had a set of blocks with circles, squares, rectangles, and triangles. If we sorted by shapes, how many would we have? Well, then it looks like we would have 1, 2, 3, 4 different shapes.